And we just not really sell Glengarry license to masonry supplies there, but lots of times Westwell Mountain, Aeroscraft, whatever it may be. Also, we are rolling out, I don't know how many more products that the Australians have brought in. And there's all kinds of unique products, so it's exciting that this is going to happen. I'd like to introduce you to Brickwork. Brickwork was with the BIA for 17 years. Luckily enough, over 3 years ago now they were? 3 years. 3 years ago, he came to us at Glengarry. We had two degrees in engineering. There is not much that Leroy doesn't know, and I will say that for a fact. And he'll say no, but there really isn't. He's the best. So, take it over, Leroy.
Thanks, Holly. How's everybody today? All right. There is plenty that I don't know. If you won't take it from me, you can ask my wife. She will assure you there's plenty that I don't know. Our topic today is going to be the basics of brickwork detailing. How many of you, when I say that, to yourselves, okay, so the only thing I really have to look forward to if we're talking about the basics of brickwork detailing is 12:30 Bishop Arlington detail. No? Okay. So I'll say this. We will go through the basics. A bunch of slides here that go over typical industry recommendations for drainage wall type of. As Holly told you, my background, I worked at the Brick Industry Association for most of my career. So if you have been detailing brick masonry walls for a long time, and you do the same things over and over again, and you kind of got this down, that's okay. This is an opportunity for you to ask those challenging questions, like, why does the IA recommend this? Why does the code say that? Why do we have to do this? And I'll be able to give you some insight on some of those issues. I'm doing exactly what he told me to do. Okay. Larry. I'll use the mouse. It's okay, Larry. All right, so as far as the course description, if we're talking about the basics of brickwork detailing, we can assume then, we know if we're talking about a cladding system, building enclosure in general, what's our number one enemy? Larry said this out. Water, right? Okay, so we're going to talk about water penetration resistance. So that'll be, sort of one of the broad areas we cover. The other thing that we tend probably to get the most questions, the most confusion about, or just people are uncertain about, I'll say it that way, is what to do when it comes to movement joints. How to detail them, spacing, what locations them at, those kinds of things. So here are actual learning objectives for today. It's basically what I just told you. We'll talk about movement. We'll talk about water penetration resistance. We'll talk about how installation and workmanship comes into play. We'll talk about different component materials. And time allowing, we'll get into some corollary items, things like use of water components, dealing with efflorescence, that kind of stuff. All right. BIA's technical notes, a good resource as far as a background. You can do a little bit more digging beyond what we talk about today, or you want to know where this information is documented. The 7 series has general information on water penetration resistance that will basically apply to any masonry wall. 8 series is where you'll find information on mortar, what types are appropriate for what types of applications, what the differences are between types. The 18 series is where you'll find your information about sizing, spacing, location of movement joints. 21, actually this has changed to update this slide. The 28 series is where you'll find all your information on specific wall systems. Okay? So 28 is brick veneer wood studs. 28B is brick veneer steel studs. 28C is thin brick veneer. 28D B now is brick and block.
Hey, can Tyson and Charlotte mute your
So
phone?
that's where you'll find that information. If you're not already familiar with the technical note series, probably one of the most comprehensive sources of information on brick construction that you'll find. It's all free for download on DI's website at www.gobrick.com. Probably got a big 4-inch binder somewhere here, old yellowing pages in it that has a bunch of these in it. Okay, but all free for download online now. So this gives us a quick idea of the order that we're going to go today, how we're going to, or the order that we're going to follow. And you can see that we're going to begin talking about movement first. When we talk about movement, anybody recognize this project? Yeah, Governor's Palace down in Williamsburg. So when we think about the way that this was constructed, we know it's load-bearing masonry, multiple layers of brickwork. But from the standpoint of movement, it's going to be similar if we look inside that wall. Stone wall.
Anyone who's called into this, can you mute your phone, please?
From the standpoint of movement, how does that behave, and how does it differ from what we do today with brick veneer? So what do we expect if we've got mass masonry? We expect a lot of movement. We expect a little movement. A little, okay? So, yes, sir.
Can you ask them to mute their phone, please?
Can you please mute your phone in?
Anyone who's called in.
Anyone who's called in,
Please
please mute your phone. Thank you. Okay, so we expect not as much movement when we talk about that type of construction because it has some limiting factors. One is the mass itself. The taller you go with this type of construction, the more gravity load you build up, all that weight actually restrains some of the movement in this direction. Okay? The other thing is, or another component or another factor is the type of wood that was used. These types of walls, basically anything probably prior to around 1930 in the United States, it's a fair assumption that it's probably a lime-based mortar rather than a cement-based mortar. Okay? So lime basically cures forever, which means, in fact, it cures slowly. It's also, a lime-based mortar is more flexible than a cement-based mortar is. So with lime, lime has a quality or a property called autogenous healing. Basically, calcium compounds in the lime, they combine with water and carbon dioxide in the air. If a little shrinkage crack forms, remember this stuff basically cures forever, right? So there's always chemical reactions going on. So over time, as little micro cracks begin to form, that calcium, that free calcium can combine with air and water, form calcium carbonate. Seals, it heals itself. Our cement-based mortars don't have much of that ability to do that because of a lower proportion of lime. The fact that it's structurally bonded. We use headers, our veneers sometimes. They have absolutely no structural function, but in this case they do. You know that there's a temperature gradient between inside and outside, right? Things expand thermally. That means stuff on the outside that's exposed to the weather. It's going to undergo more movement than the stuff on the inside. It's probably a smaller range. But if it's all bonded together, that means that the inner layers also restrain some of the movement of the outer layers. Does that make sense? So if we fast forward 100 years or so, and the way that we build now, and that is why with a lot of most of your mass historic buildings, even though they have walls that are quite long, quite tall, no movement joints, and they don't experience the cracking related to movement. But now, of course, we're saying we need them every 20 to 25 feet. We need them roughly every floor. And the reason is because the brickwork still expands, but we don't have those things that are acting to restrain that movement. If we're putting a shelf angle at every floor, that means there's not, even of its own weight, not a lot of load on that brick. So it's very free to expand. It's very free to expand to the sides. There's no other layers restraining it. The only thing holding it basically is those little 3/16" diameter wire ties that we put every 16 inches. It's thoroughly isolated. We've got insulation behind it. You know, so the temperature range that it experiences is greater than what we would have seen in those other walls. And that's why we have to design and accommodate movements. So managing masonry movement. We've already identified what our primary strategy for dealing with movement is. And that is to accommodate the movement or allow it to occur. We do that with expansion joints, control joints, bond breaks, slip planes, those kinds of things. Are there any other strategies that you can think of besides accommodating the movement? Okay. You're hungry, so I'll give you a break. I'll help you out. One of them is that we can resist or restrain the movement. Okay? Now, that's not our preferred strategy because it's usually restraint conditions that actually cause the problems that we're trying to avoid. But a good example of this is in concrete masonry. Okay? We're designing a concrete masonry wall. Concrete masonry shrinks. It develops tensile stresses. It wants to pull itself apart. So what happens then when we take wire joint reinforcement and we put it in the bed joints? What do we know about steel? What's steel really good at? Resisting tension. So that steel is going to resist those tensile forces. So if we design a concrete masonry wall and we put no horizontal steel in it, we would have control joints closer together. When we put horizontal joint reinforcement in it, it allows us to put those control joints farther apart because it's restraining some of that movement. So in some cases, this is a strategy that can work for us. But usually, we default to the first one. The third one is taking a look at the actual materials that we're using. Okay, so we're doing a masonry facade. Let's say, that's actually not intentional. Well, let's say we've got some banding in there, okay? We've got something we want it to have sort of a limestone kind of appearance. Okay, some limestone looking banding. So material-wise, what are our choices for that banding? What can we potentially use? Cast stone, okay. Precast concrete. Real stuff, natural limestone we could use. Okay. Anybody ever heard of calcium silicate masonry? All right. So I don't need to see the trade name. Say the trade name, you know what I'm talking about, right? So from an aesthetics standpoint, they will all achieve the function that we want, right? So now let's look at it from the standpoint of which one of those materials is going to behave more or most like the brick, in which case we don't need any special detailing for movement. Natural stone generally is pretty stable. Doesn't do a lot dimensionally. It depends on the stone. They're all a little bit different. But it's usually pretty stable. So maybe, maybe not. All right. Anything that's cement-based is going to shrink. Brickwork always expands. Okay. Anything cement-based is probably going to have some special detailing required. The calcium silicate masonry, if you look at their literature, it expands a little. It's the one that actually behaves the most like brickwork. And if you talk to them, you look at their recommendations, they'll tell you no special detailing. Okay. Versus if you look at the Cast Stone Institute's technical manual, and they'll tell you you need to put a sealant joint or a slip plate. So that's one of the considerations. There are other things we're obviously familiar with, like if we're dealing with wood. If we use engineered lumber rather than sawn lumber. Not quite as much shrinkage. It's going to cut down on the All right. Any questions before we move on? This is one of my favorite parts. This is where I get to confuse people. And then I get to clear up that confusion. So let's take a look at this. I've probably done this here before. You've got a facade. You've got a couple of joints in that facade. One in the middle, one in the center. How many of you would agree that is correctly labeled as a control joint? All right. I see some people shaking. I see some people nodding.
That's what we call it. They call it fancy joint.
Okay.
What
So
British people call it.
exactly. He says that's the way brick people talk. That's exactly right. If you look at the Brick Industry Association's technical notes, absolutely every time they refer to a movement joint in brickwork, they will call it an expansion joint. I know you know that is the big thing with the bellows joint. It goes all the way through the building. There's a reason why they do that. At this point, I'm a reformed BIA employee. I don't care what you call them, all right? As long as you detail them properly. So I want you to understand that movement joints behave differently depending on what you detail them and what material you put them in. All right, so I'm a brick guy, but the easiest example is concrete masonry. So let's think about a sidewalk for a moment. Sidewalk has control joints in it, right? What are those control joints actually doing? Concrete is a cement-based material, so we know it shrinks. So when we put a movement joint in a shrinking material, how does it actually accommodate the movement? What does it need to do? It cracks. Why does it crack? Because you got tensile forces, and it pulls itself apart. It pulls itself apart because we've created a plane of weakness. That's the critical thing. In order for a control joint to function, all you have to do is create a plane of weakness. So, let's apply that now to concrete masonry. Let's talk about concrete masonry. Can I form a control joint that has mortar in it, but I just use something like a piece of building paper in that joint, create a bond break? Does that work?
Mortars on the face.
Okay, so let's say I have a block here. I have a piece of building paper. I have a mortar joint in my next block. Can that joint open? It will open because you've got a bond break there. So you can have mortar. You can have material in a control joint that is not compressible because the joint's going to open. Now let's think about brickwork. I already told you, brickwork always expands. So I have mortar in a movement joint in brickwork. Okay, why not?
You can. It'll come out.
Okay. Just do it. So in brickwork, because the brickwork wants to expand, what we have to do is we have to create space for the brickwork to expand into. That means we got to go completely through the material. That means if we have anything filling that space, it has to be compressible. Okay? Sounds like we all have a pretty clear understanding of that. Agreed? All right, we'll move on then. You don't want anything crossing your movement joint. No ties, no joint rings, anything like that, because it can translate those stresses across the joints. Now, technically, I see you there. Technically, there are some anchors that can be used where you have intersecting walls that allow the movement to occur, but generally, you don't want anything crossing. Yes, sir?
Question is, how important is that size going?
It's not important at all. Actually, if you look at recommendations for clay brick and you look at recommendations for concrete masonry, for example, they're not exactly the same. You can make it so that they align, but generally you need your movement joints and concrete masonry a little closer together. A lot of people would say you don't want them to align. Those are planes of weakness in your facade areas where air, water, bugs, whatever might get in. So actually having an offset might be a benefit rather than having it combined. Any other questions before we go on?
Is the brick tile in conflict with that? Or we have a plate of brick tile? If they're shifted, not to inflict.
Okay. Did everybody get the question? He asked about the ties. And is there enough play in the brick tie, basically to account the movement, for the movement?
If they're not aligned.
If they're not aligned. So yes, simple answer is yes. There's enough play in the brick. All right. So really quickly, the driving forces behind these movements, I think we're probably pretty familiar with. Changes in temperature, responses to moisture, and then sometimes the effects of loading. If you ever have trouble sleeping, I highly recommend BIA's Technical Note 18A, where you'll find the long versions of these equations and a whole lot of factors that you can consider. But basically what it comes down to is moisture expansion and thermal expansion. So, I've said a couple of times now that brickwork always expands. Why does brickwork always expand? And before you answer, the answer is not here. That's misleading. That's the next thing I'm going to, okay? So why does brickwork always expand? It's clay, all right? You got to give me a little more than that, because we know the way that clay responds to water is that it shrinks and it swells. All right? It absorbs the moisture from where? Everywhere. When? See, that's where I got you. It's not about all the time. All the time isn't the issue. How do we make brick? All right. Yeah, we fire it. So when we're done firing it, there is no water in it. Zero moisture content. Then it comes out into the real world where we live. So immediately, its moisture content goes, and then it levels off. Okay. It's this. That's the reason why brickwork always expands, because it's going from zero to equilibrium. Is it ever going back to zero moisture content again? Yeah. That's why brickwork always expands. It's got nothing to do with rain, any of that stuff. It's a fire material. So that explains the moisture component. On the other side, we have thermal component. We know everything responds to temperature. It goes up, expands, it goes down, contracts. So what you can see here, and these numbers will vary based on the sources, is among masonry materials, the coefficient of thermal expansion, they're all kind of in the same ballpark. So the thing that makes differential movement between masonry materials is the moisture component. Where temperature becomes a problem is the difference between... Okay, can you please mute your phones? Really relevant issue from a thermal standpoint is the difference between masonry materials and things like metals, dissimilar. So here, obviously, and we know steel expands a lot more than your masonry materials do. So that means anytime that we have metal that is surrounded by masonry, encased in masonry, attached to masonry, we better be leaving some space underneath it, some space around it. We better have an adjustable connection, something that allows that additional expansion or movement in the metal to occur. This is an example where that didn't happen. It was an apartment building, mid-rise apartment building in New York City. Had a walkout roof above like third story. This was a number of years ago. So a lot of solar absorption. Since it was a pedestrian area, they put bars on all the windows for security. They set them inside the returns and the window jambs. Everybody probably can't see this, but right here, and every other jamb at that floor level in the project cracked. Because as you can see here, the bars are tied in the window jamb and the return. There's nowhere for that metal to expand. You can also see that the connection is also in here on the returns. There's a number of things that could have been done differently that would have improved that situation. A little bit of space between the masonry and the metal. You can avoid that. Take that that connection. I know it's not the best looking thing, but if it's out on the face, you got a slotted hole that can move, then they could probably have prevented those types of issues. So very simply, movement joint spacing. We typically want our movement joints to be about the same size as our mortar joints, just for aesthetics. So that becomes our constraining factor, our governing factor. So does anybody see anything here that's a surprise or you didn't already know? All right, so that means I have to add some value. I'm going to tell you corners, 2 to 10 feet from corners, okay? So that's a little surprising because you're probably saying, no, we want them within 5 feet of the corners.
Well, not us. Oh, about 2 feet.
Within about 2 feet. Okay. I will not argue with that. This, that 10 feet number, let me see if it's here. Okay. That comes from BIA's technical note. That is the most liberal recommendation for the placement of joint near the corners that you'll find in the masonry industry. Just about everybody else says within 4 to 5 feet from the corner. Yes, ma'am.
So I read that a couple of times that it's well consistent, but looking at it, are they? I was wondering if the 10-foot rule is more for that outside corner, but it kind of looks like for an inside corner, if they want it.
Okay. All right. Let's take a look at some conditions. This is what they're trying to avoid. All right. So we know from this, we need a joint roughly every 20 to 25 feet. All right. So I look at my facade. I'm going to try and make it work to my benefit aesthetically. So what's my main facade? Let's say it's my, west facade, whatever it is. I turn to that sheet on my elevations, and I start from the corner, 20, 20, 20, 20. Now I flip to the next page, my north facade, 20, 20, 20. Well, if I do that, I've got 40 feet additive around that corner. I will always end up with a crack in that condition. So that's the main thing they're trying to avoid. What they say here basically is as long as you have one joint within 10 feet of one side, and you follow your maximum spacing as you go around the corner, you should be okay. So now inside corners. Inside corners are a little bit different. I would say the ideal place, well, I'll say it this way. Inside corners are an ideal place to put your movement joints. It's rare when you come to an inside corner that they're actually going to bond those walls together, that they're actually going to tooth them. That means you have two walls that are butting each other, and you have a continuous vertical joint, a mortar joint between those two walls. Anytime you have a continuous vertical joint like that, it's going to crack due to movement. You've got two walls that are expanding in different directions. So since you're going to end up with a crack there anyway, don't make it a mortar joint. Make it a movement joint. Back rod sealant, compressible filler. Now you've dealt with the potential crack. You've addressed that. But you've also dealt with your spacing. And now you can go, your 20 to 25 feet on either side of that. Any other questions about that? Okay, so similar condition here. So when we have a corner, this is what's happening. I know many of us probably seen that vertical crack that follows that first head joint right up the wall. All it takes for that to happen is just simple expansion of the brickwork. You've got walls that are expanding toward their ends in perpendicular directions. They're trying to push each other off the wall. Usually the longer wall coming into the corner wins. So in that case, normal corner, we have two perpendicular walls. When we have this kind of condition, what we have is two walls that are parallel to each other that are joined. because these two walls are both expanding toward their ends, that has the effect of doubling the amount of stress. You know, it's equal but opposite directions. They want to rotate that piece that connects them. But again, you always have an inside corner in this condition. Continuous vertical joint, that's a good place for the movement joint.
Does it matter which, if it's in the bottom, does it matter which joint you're using? The outer wall or the inner wall, and the actual true inside?
It doesn't really matter. You can make an argument as to which, I'll put it this way. If we're looking from this direction, then when you put it there, that's what's going to hide it. I mean, you'll hide it here as well. But this one typically is where you're going to have it bonded. You'll follow your bond around this corner.
We're thinking, I was looking at up being outside.
Okay. So the inside corners, that's one of the things that works to hide some of those joints. Other things that we can do to make them less conspicuous, you can use a band of a different color or projection or recess, different texture, those things work. We've seen people even use shapes, and because the eye is drawn to the shape and what's happening with that, you don't realize that there's a movement joint there. In the top right, can everybody see that there are two movement joints in that top right photo? All right, so that's illustrating the impact of sealant color. The default for some reason seems to be that we match the sealant color to the mortar color. That interrupts the bond, so it's a very good way to make sure that your vertical joints stand out. If you want to hide them, match the brick color.
All right, that's it.
I'm sorry.
You don't know what type of can of worms you open. That's years to be.
I know exactly what kind of can of worms. But here's the evidence.
Match the brick.
Until it fades, and it's not that color anymore. And it's
Okay.
looking like a race.
When it fades, is it really going to look like that, though? It's still going to be cool.
Look like either.
I mean, somewhere in between. Okay. I didn't say it was absolute. It's better.
You know what God you did.
All right.
The brick, right?
I know none of us like their food, but we go there anyway. Take a look at McDonald's. McDonald's, they use brickwork a lot, and in a lot of cases they have banding. There's usually 2, sometimes 3 colors of brickwork, and what they do, as the color of the brick changes, they actually change the color of the ceiling. Yes, sir. I saw your hand.
I want to move on that same section, move up to the edge.
What happens? Do you jog out? Is that what?
it? Or do you jump the lintel?
Okay, so I know we all love the way that looks when the joint aligns at the sill and then you go up and then it jogs out 8 inches and then you come back over. It's awesome.
Only if it matches the brick.
Only if it matches. What's the reason for that?
Have a brick lintel, and it bears masonry.
Okay. All right, so it's usually when we see that is when we have a loose lintel, which means we all probably learned or familiar with the, at some point learned about that 45-degree triangle over an opening, right? So that's the load that the lintel carries. That assumes something, all right? Got brickwork and running bonds, half running bond. That means we've got a distribution of load at that 45 degree. So what we're assuming with that triangle is that we have arching action in the masonry, that the masonry is in compression. If we don't carry that joint out to the end of the lintel, we don't have compression in the masonry. Movement joint interrupts that. So instead of this 45-degree triangle, it's that 45-degree triangle because you're only racking up one side. It doubles the load on your lintel. If you got a small opening, it's the same size lintel. The amount of deflection isn't enough to cause a problem. It's not an issue. When you have a larger opening, then it could potentially become significant. That's the reason why we see that. So, do we have to do it? No, we don't have to do it. First thing is, great timing, by the way. First thing is that when we have a loose lintel, there is absolutely no reason that we have to have a movement joint because we have a lintel there, a vertical movement joint. Okay, so that's a little bit different than when you're doing concrete or structural masonry. So one option that we have is, if it works better from the standpoint of aesthetics or symmetry, don't even align that thing with the opening. Put it in between the openings. And then you eliminate that disgusting detail. Okay? So there's nothing that makes you have to do that. If you do, fine. In technical notes, ABI actually has a detail where they show how you can align it at the where you don't actually jog out. And what you do, let me see if it's in here. I don't think it's in this room. Well, maybe so. All right, this is it. But basically what you do is you provide, make sure there's a slip plane there, and you run sealant out to the end of the lintel bearing, but your joint can continue up straight. All right. So just looking at some other locations, when you have walls that are significantly different in thickness or height, they're going to expand them out, so you want to isolate those. You have different support conditions. You want to isolate them from each other. You don't want something that's bearing on the foundation and subject to, what do you call it when the ground goes down? Settling, yes. Subject to settlement, bonded to something that's going to be supported on steel and not subject to that settlement. Get settlement in one area, it's all bonded together, you end up with cracks. The brickwork expands exactly the same amount in the vertical as it does in the horizontal. So, that's the primary reason why we have to have shelf angles in our buildings. It allows us to break up that movement and be able to deal with it. We want to make sure, just like in our vertical movement joints, remember we said we have to provide a space with nothing that prevents that joint from closing. So in this case, do we have something that prevents a joint from closing? The angle itself. So what we have to do is we have to make sure that there's enough. You load the angle to accommodate the movement. And you cannot have mortar because mortar is going to prevent the joint from closing. So only sealant, backer rod. You can put a compressible material in there to fill that space. All right? So I like to give this example. This is what you'll find in BIA's technical notes. Pretty standard shelf angle detail where they recommend a minimum of 1/4 of an inch of space below that shelf angle. All right? That's to accommodate the movement. There's an assumption that's made there that you never see. So under what conditions does that 1/4 of an inch of space work?
Different floors.
Okay. Let me give you a design example. We have a 4-story brick veneer metal stud building. So, code says, you got brick veneer, metal studs. Once your veneer exceeds 30 feet, you need non-combustible support for every story above the 30-foot height. So, at the very least, we got to have one shelf angle. We got to hang it somewhere off the 4th floor or something like that to carry that top floor brickwork. If I do that, does a 1/4 of an inch of space below that angle work for me? Doesn't work. Because we still have 3 floors of veneer beneath that shelf angle that need to expand. We expect about 1/4 of an inch per story. So in that case, you would need a minimum 3/4 of an inch of movement. You end up with a joint that's probably about 1 inch wide, or maybe a little more, and that's why we make lift brick. because that helps to reduce the apparent size of that joint by having the brick that simply hangs down in front of the toe of the angle. Right? So just like your shelf angle, any other element that is attached to the structure but extends out into or through your masonry, you've got to accommodate that movement. Got to make allowances for that brickwork to expand without creating a restraint condition. That's what happens when you've got mortar in front of the toe of the joint, or in front of the toe of a shelf angle. Basically what's happening there, remember, that angle is supporting most of your brick. So you've only got a little bit of mortar in front of it. And that mortar is basically sitting on that section, let's assume it's a cord brick, in front of the cores. So you've got an edge loading basically right on the plane of weakness. So you end up crushing the mortar, swallowing the face of the brick. All right, that's our overview of movement. Anybody have any other questions on movement? All right, we'll switch gears. We'll talk about water penetration then. Let's do this, because a lot of the stuff, typical recommendations, I'll assume you know. So let's take a look at some examples. You can see this is a masonry element that is experiencing some distress. So take a moment, digest it, tell me what issues you see, what we could have done better, and probably prevented the problems that we see from occurring. Yes, sir. Put a cap on the top. What's wrong with the cap? It's brick. It's awesome. It's got a lot of joints in it. The more joints you have, the more potential for water penetration you have. Okay? Anything else? Weep holes, absolutely. Okay? Because even with this cap that we have, if there was flashing directly underneath it, that prevents that water from going any further than that point. Okay? Any other observations? So this is obviously not a building wall. And sometimes we're asked if I'm doing an entrance sign or a trash enclosure or one of those types of things, should I still design it with an airspace in it, or can I build it all together, do like composite wall construction? All right, so what's your thought as far as that? Cavity wall, why? Okay, so I'll give you something else to consider. This is a good example. Take a look at this element. That's brick, right? And a mortar joint, modular size brick. That means that dimension is 15 5/8. So 16-inch square column, 15 5/8. So look at the next course. We can see that's a full brick that turns the corner for that 4-inch veneer on each side. 4 inches on each side. We can see there's a full brick in the middle, 7 5/8 inches. So if we imagine that there's also a 7 5/8 inch square block in the middle of that element, how wide is your airspace? 0. Okay. Does brick absorb water? Okay. There's no airspace, so we can assume that behind that brick, whatever space there is, it's effectively full of mortar. Does mortar absorb water? Yes. Behind that mortar, you have concrete block. Does block absorb water? Yes. Or if there were concrete back there. So when they're all in contact, not only do you have water being absorbed on the outside, but by capillary suction, it's saturating everything in that element. The same thing is true with your trash enclosure, or entrance signs, all those things. Okay? So, what is the primary contributor to efflorescence? Water. Okay. Water's not the origin, though. Water's the activator. Salts. Where do the salts come from, primarily? I'm hearing some different things. Somebody loud and confident. Fine, I hear. I heard mortar, I think. Portland cement. Portland cement. So mortar, yes. Grout, yes. Yes. Cast stone, yes. Precast, yes. Anything that contains Portland cement has high concentrations, primarily of calcium, sodium, potassium compounds that are going to come out as efflorescence. So when you build this all together without an airspace, you're increasing the available soluble compounds, and you're increasing the amount of water that's available to dissolve them because it's all going to be absorbed by capillary suction. All right, enough about that. Drainage walls, we know we should be doing that. We're talking about building enclosures. We know how they work. Let's look at individual elements really quickly. Yes, ma'am. Yes. If you want to reduce the potential for efflorescence, if you also want to potentially extend the longevity, the durability, the performance, because it's really simple, okay? The faster we get water out of masonry, the faster we dry. We want to prevent efflorescence. We want to reduce the potential for stuff like freeze-thaw damage, right? Those problems only occur when the masonry is wet. If there's no water available to freeze, it doesn't matter how cold it gets, okay? So the faster we dry it, or the measures that we take to get it dry as quickly as possible, that helps basically with any water-related issue. So that's a primary thing with those elements. So air spaces, we know the code says they have to be a minimum of 1 inch wide. BIA for commercial wall assemblies has always been a proponent of making them at least 2 inches. Why 2 inches? What's wrong with 1 inch? 1 inch gets blown too easily, all right? Mortar has a gravity-defying property. When you put brick down in mortar and it squeezes out on each side, it will defy gravity for 1 inch. It'll create a protrusion. It will bridge a 1 inch airspace. Can't bridge a 2 inch airspace. It's not that good, all right? So that's why they've always recommended 2 inches. Now, very often we have continuous insulation in our cavity space now, correct? The recommendation changes a little bit. BIA says, as long as you've got 1 inch clear between the back of the brick and the face of the insulation, that's acceptable. You don't need 2 inches clear. Why is that acceptable? Are we going to get mortar bridges? Yes, we are going to get some. So why is that acceptable then? Because your insulation itself is a barrier to that water continuing to travel toward the interior. Okay. So, but it still needs to remain open enough to allow your water down to your flashing weeps where it can exit the wall. If you want rain-screen performance, I would say 1 inch is not enough. Okay? Because of the mortar protrusions. You probably need to be at least 1.5 inches, unless you're doing a drainage mat or something that actually prevents the possibility of some mortar blockage. Okay? That's why we have collection devices of different types, either to keep the weeps open or to prevent mortar bridging altogether. Is everybody fairly familiar with those products? All right, see lots of nods, so I'll move on. Water-resistant barriers, I'm going to leave most part to those guys when they come and do lunch and learns with you. Sheet materials, we've got, of course, we know they have to be lapped, shingle style. We've got self-adhered membranes, and then we've got spray and fluid applied. Aside from installation, what would you say is the biggest factor that determines how well these material categories perform?
Transitions.
Transitions? Okay. which I would say is still sort of an installation, but yeah, definitely transitions, how you deal with them. What else? Penetrations, okay, that's definitely a good one. One of the biggest ones I see is how long that thing is going to be exposed before the brickwork goes up. It's one of the things that separates these classes of materials in terms of performance. All right? Some of them do better than others. I'm going to assume you probably know which ones perform better than others from that respect. All right? So our water resistant barrier, of course, is integrated with our flashing. Either we're going to lap it over our flashing, or we're going to have a termination bar, some sort of mechanical connection between them so that we can get the water out of the wall. Critical points for the flashing: top of the wall, the top of an element, which you've already identified. Then gravity takes over. Once the water gets in, it's trying to make its way to the bottom. If it's not getting to the bottom, then whatever is preventing it from getting to the bottom should probably be flashed. Things like our window and door openings. When we get to the bottom, of course, we want the water to exit there, so that's our other place. You can get some information on material requirements for different types of flashing in BIA's Technical Note 7A. You basically got 3 classes of material. Old school, heavy gauge, bring out a metal worker, sheet metal, copper, stainless steel. They're 100-year materials, almost indestructible. You're going to pay for them. You got a composite or laminate class of materials that take advantage of multiple materials. Sometimes they have metal in them, which gives them good puncture and tear resistance, both from a budget and a durability standpoint. This is a pretty good class of materials. It works well for a lot of different project types. One thing to be aware of, this is where stuff like asphalt-coated copper used to live. Anybody familiar or had a project with asphalt-coated copper before? All right. Here's the problem with asphalt. It doesn't play well with basically everything else that we use at this point to try to control heat, air, and moisture in our wall assemblies. Doesn't play well with foam insulation. Do you ever use foam insulation? Okay. Doesn't play well with spray, fluid applied air barriers. Doesn't play well with some sealants. So if you're using it, just make sure it's compatible with materials that you're using it with. Otherwise, and the industry is moving to asphalt-free alternatives. Everybody that was making one of those asphalt types of flashings at this point probably has an asphalt-free alternative to it. Third category, plastic and rubber compounds. Big benefit of this class is the low cost, easy workability. There are some winners and some losers here. In general, if you stick with the stuff that is sort of like come over from the roofing industry, thicker material, 30, 40 mils minimum, you tend to do okay. Thinner material, really high in recycled content, not a lot of plasticizers, we have trouble with. How many of you have seen buildings in Baltimore or DC or, other larger cities where they're taking out the brick at the shelf angles, every floor, every other floor? The primary reason that happens is not because of a movement issue or because of a problem with a structural issue or a problem with the brick. It's because those buildings were built in the 70s or the early 80s with polyethylene and PVC type flexible flashings, and they basically turned to dust. They have to be replaced. All right? These materials tend to be UV sensitive. If you look at the cut sheets for them, the manufacturers offer and recommend that they be held back from the face of the wall. That's obviously going to be a problem for us from a water exiting standpoint, so they need to be used in combination with drip edges. Seals. There's a lot to pick apart on this detail, okay? There's just a couple of things that I want to point out. Number one, old school detailing. Having seals that actually have a slope on, that actually extend beyond the wall. it actually have a drip on the underside, all right? It may not seem, especially if we've got a one-piece sill that we need on those elements, they actually do a pretty good job on their own. But if for some reason something goes wrong with that flashing, there's a gap, it wasn't installed properly, what have you, those things prevent a lot of water from entering at that point. All right? So you can see I have this represented not as a brick roll lot because of all the points that would be there. So if this material is something like precast, which we've discussed is a cement-based product, do sills ever get wet? Okay, so it's going to become saturated, which means there's a potential for efflorescence there. Is there a benefit then of actually having this piece of flashing here rather than a course or two courses down? Absolutely. It's a capillary break. It means that that brickwork now cannot directly absorb soluble compounds from your trim. Mason hates that. The reason the mason hates that is because when he puts the flashing there, that means there's nothing for his sill to bond to. And he has to now put an anchor through his flashing, which makes us want to gasp. It's a horrible thing. They can seal around it. It's going to do a better job anchored, sealed with a mastic than if they leave that flashing out. All right. BIA likes open head weeks. The reason they like open head weeks is because they're big, which makes them harder to clog and gives you the opportunity for air to get in. I mentioned the benefit of drying. So 20 inches is a typical recommendation for the spacing of open head weeks, or if you want to put a vent or insert in them, that's considered equivalent. Code allows you to go 32. If you're using a small weak tube, rope weak, those kinds of things, no more than 16 inches is recommended. Again, the vents give you the potential to promote drying. Questions? A couple more things I want to share with you. All right? Concave and V. These are your most weather-resistant joint profiles. They compress the mortar, which reduces absorption, and they press it up against the edges of the brick, which closes off that interface where the water wants to get to. All right? You always want to observe your hot and cold weather construction measures, okay? What they do is they make sure that your materials and the resulting mortar stay at a temperature that it can hydrate properly, that it can gain strength properly, but also that it can bond to the brick. If you don't have good bond between brick and mortar, you're not going to have good water penetration resistance. That's the number one measure right there for preventing efflorescence. All right? My favorite example is Thanksgiving weekend. That mason is leaving early on Wednesday. If he does not cover the wall, it will rain and snow all weekend. If he's sober, he'll be back on Monday, at which point we'll find out that the wall was left open in April. It has to dry out, and those soluble compounds begin to crystallize on the exterior of the wall. Number one measure, covering the walls when they're not finished. Prevents those walls from getting saturated and taking those soluble compounds into solution. Type N is the recommended type of mortar for veneer, for clay brick veneer masonry. Type S is stronger. The reason why BIA and other organizations say do not specify a mortar that is stronger than what you need for the project. Let me say that again, because you might think that what I just said, I didn't intend to say. You do not specify a mortar that is stronger than what you need for the project. The reason is, as your mortar gets stronger, the reason is because, by proportion, your cement content is going up. As you increase cement content, the way that cement hydrates, or what happens as cement hydrates, is it shrinks. So as your mortar gets stronger, you're also going to have, as a result, more shrinkage cracking. The other thing that happens is your lime is what makes the mortar workable. So as your mortar gets stronger, it becomes harder to lay brick with it, which makes it harder for the mason to fill the joints. So, in effect, a stronger mortar, you're giving up water penetration resistance for that strength. So, use the weakest that is permitted for the we always want end downs at the end of flashing. That's simply where the end of the flashing is turned up. If we're using a flexible flashing, look at what happens to it when it crosses our drainage space. We get a trough. Yes, sir. The drip edge? Generally, the drip edge is left flat. I have seen a drip edge turned up, but usually as long as you have an end down on your flexible portion, you can just have a flat drip edge and it works fine. You can get preformed end downs, preformed corners, those types of elements. Do you need them on every job? No. In some cases, it depends on what type of material that you're working with. EPDM, for example, it's stiff enough that it's kind of hard to patch and fold into these elements. So preform works good with that. Also, if I have a job that looks like that, I'm using some preformed elements. I'm not relying on the least skilled mason on the job to get that right every time. Something to consider. I've run through basically all the information that I wanted to share with you. Is there anything, any burning questions anybody has? Is everybody, I would assume everybody's probably pretty familiar with efflorescence. Okay. So any other questions, either about material today or brickwork in general that I maybe can address? Yes, sir.
Kind of diagram earlier of a precast fill, so like 15 out of it.
Yep.
That same
If it's like 15 degrees, usually you're not going to find that much slope on a, well, I won't say usually. You won't always find that much slope on a precast sill. Probably more like 6-7 degrees. If it is a roll-lock sill, I would put as much slope on it as I could stand, just to get the water away from those joints as quickly as possible. So yeah, 15 degrees is more of a recommendation for a roll-lock.
Yeah, that's true. Yeah. But
They used to. I think now it just says slope to the right. If you look at older versions of the technical note or in some older technical notes, I think you can probably still find that 15 degrees in there somewhere. Yeah. Yes, ma'am. Yeah. If I'm going from 2 inches to 1.5, I'm probably not that concerned. If I was starting with something smaller and had, maybe more rustication in it, definitely you want to make sure that you don't at any point get less than 1 inch. Number one, because that's what the code says. Number two, just from a practical standpoint, let me point out something. We build a wall. We've got construction tolerances, okay? What is your tolerance for plumb on a masonry wall? How far can that wall be from plumb? 1/4 inch. 1/4 inch and 10 feet, 1/2 inch over the wall, okay? Then we got the backing on the other side of that wall. it's got a tolerance. It's probably going to be at least that. If it's concrete, it's going to be more than that. That means if I start, I've got that nice 1-inch airspace that I put on my drawings, and it stays 1 inch all the way up and all the way down. But in the real world, I can have a wall that's in plumb. I can have a backing that's in plumb within tolerances, and I have 0 airspace. So we definitely don't want to start there and impinge upon it. Like you said, if I'm starting with 2 inches and, you know, I'm doing like a 1/2 inch reveal, that doesn't concern me a whole lot. When I'm doing more than that, yeah, I would say definitely don't, at any point, let it get less than the 1 inch. Because the other thing to consider there is that in a brick veneer, your drainage plane isn't really where your water resistant barrier is. It's the back side of the brick. So the other thing that happens is that when you provide that rustication, the more that you have it, the more you slow down the water as it sheds down the outer face, but also as it drains down the inner face. So does that answer your question? So there's no hard rules, I would say, other than the 1 inch. You know, I wouldn't impinge upon that, but yeah, it's definitely something to consider. Other questions? Yes, sir.
If you're doing a retaining wall, would you still take the same airspace approach?
So basically the retaining wall is something else, but it's brick faced, or is it?
If it was brick based, concrete. If it was block and brick based retaining wall.
If it were me, I would. Another thing potentially to consider, let's say if it's concrete backing,
Don't take that.
you could apply like a waterproofer to the concrete, something that would potentially prevent the transfer of those soluble compounds, and that would be a way to do it without having to put the drainage space in there. Okay, other questions? Okay, thank you for your time today. As you can see, I'm sorry? A card, yes. I have some cards if anybody wants them. We pride ourselves on being able to do more than just supply masonry materials. We like the fact that we're able to try and provide design solutions. It's not just me. We have team, we have Holly, we have guys that specialize in just, you know, accessories, insulation, ties, all that kind of stuff. So, yes, sir.
I have a question about veneer anchors. The standard veneer anchors are designed for 4-inch cavity from the back of the brick to the face of the block or sheet. And we get an instance, as Kat mentioned, where we're doing some rustication and snouts or some piers, and that cavity wants to be wider. And code says anything is you have to have special engineering and things like that. Does that actually happen? What steps do we have to take to make sure that that happens, other than specifying it? Because even in those instances, I've never seen that type of engineering.
Okay.
Well, that's the other thing.
Well,
Installation
they
gets
changed it's not.
Very good. Okay, did everybody hear the question? So the question relates to basically our energy code requirement. We have the pile installations in the cavity space now, which means our ties are required to span longer distances. And what happens when we got to exceed that 4.5 inches? And so you're absolutely right. As of 2016, the masonry code that we reference in the building code has changed such that basically with any tie, you can go 4.5 inches. Okay? And that's actually changed to 4 5/8 because we figured out 4.5 doesn't really work. You use a 5/8 inch sheet. Okay. It's increased if you use basically certain tie types. At this point, have already been tested. We've already done the research. We've been having to provide a document for roughly 10 years now to say that they can exceed 4.5 inches. And so the limit for certain tie types now is 6 5/8 inches. So basically, if you have a 2 pencil top where the backing does most of the work and the adjustable part doesn't span more than 2 inches behind the face of the brick, you're good. I mean, the back of the brick, you're good up to 6 5/8 inches. Above 6 5/8 inches, that's when you have to provide that documentation. So that does help with a lot of common conditions that we see, but there's still going to be some that exceed that, and at that point, we have to provide documentation. So yeah, it does happen, and it costs.
I appreciate everybody attending today. I truly do. You look at the resource. There's development team. I don't know how many teams they have now. Like areas, bought L&L 5, where you were $1 companies bought up. There's architectural, engineering, resource for anything. And we also, if you'd like, I can get you an accessory, lunch and learn with Public Veneer. We just try to bring value to you. We just try to bring value to you. So if Public Veneer is not very, I don't care. So whatever it may be that you feel you need a lunch and learn.
You answer your question, ma'am?
And tell me, I'd love to have it. Yeah, I'm happy to. So I'm here. You don't have my contact information. Just try to get it if you want it. I'd love to take it, but I got it. I've been through this for over 60 years. I got it.
But it's still.
Okay, well, is there a question at one of the other locations?
Yeah, Leroy, we have a quick question. Back on your conversation about the movement joints and the relationship between the movement joint in the brick and in the block backup.
Yes.
I didn't catch the full verdict or recommendation on their proximity or alignment.
They do not need to align at all.
Right. So if, for example, we showed where we wanted the movement joints in the exterior elevations in the brick,
Mm-hmm.
but didn't specify where we wanted them on the block,
Mm-hmm.
what do you feel is a fair assumption in terms of installation?
Oh, that's a good question. Usually because the block is structural,
Yep.
you would see them on the structural drawings, or the mason would, I guess, space them however he would normally space them. But generally, you wouldn't see the ones in the block on the architectural drawings. You would see them in the structural drawings.
Okay, that's exactly what we had. We had them in structural.
Okay.
Okay, cool. One other question.
Sure.
We have a existing building, brick building from the 60s that had a recess at the top, a detail, and so a horizontal brick lip essentially on that recess, and it was recommended that we use a cement wash to slope out on that little bit of brick.
Sure.
It was our understanding that as long as that existing brick was cleaned and prepared properly, that there wouldn't be an adhesion issue or with that cement wash. The superintendent on the job, who's a mason, has basically raised concerns about doing that it won't stick or won't benefit. Do you have any say on that?
How big is the recess?
My guess is 2 inches or so. It's about
Okay.
maybe a little more. Okay.
So, yeah, with 2 inches or more, I would think that would be recommended. It would be better than having a 2-inch, shelf sitting there.
Yeah.
In my experience, or the things that I've been told, is that even though a mortar wash is helpful and often recommended for something like that, it's not going to last forever. Eventually, it's going to deteriorate. But, generally, being able to provide some slope or something that sheds water up there would be recommended.
Okay. All right, thank you so much. This is great.
Okay, you're welcome.
All right.
What's your thoughts on for existing masonry? For example, it's a renovation and we're re-roofing the building. There's a little part of a high roof and there's brick around it for 4 foot. You know, it's with roof steps up. And currently it just, flashes to the bottom and there's coping on top. And now people are concerned that water's gonna, get in there and they want to cover with a membrane. And so it's suggested to just use a waterproof coating on that brick to try and seal it, keep water from coming through. It's like it's just 4-inch brick, 4-inch block. It's like a barrier wall. That's all it was. It was from the 60s or whatever. What's your thought on those kind of products? Most people don't like them generally.
I'm not sure that I'm completely following everything that's going on.
Yeah.
With the condition that you described, but in general, the way that water, first of all, with water repellents, the only thing that anybody generally recommends is going to be a breathable penetrating type. If you apply a water repellent only works where it's applied, which means if water gets in somewhere else, it's not helping. And if it's a film former, then it's actually trapping water at that point. So the way that water repellents work, the breathable penetrating type, is they reduce absorption.
Right. All pores and everything.
Right. So from that standpoint, I can see there being some benefit, but if there are things like incompletely filled joints, that kind of thing, the water repellent isn't going to help. But in general, I would say a water repellent is going to be more helpful for a barrier type element than it will be for a drainage type element. So yeah, like you said, generally the thing is, well, no, but we are talking about existing masonry and not new masonry.
Not a lot of it either. It's just, otherwise you have to cover it with metal or cover it with roof membrane or something. There's other choices.
I'd like to see a little more to make sure that I understand it. If you want to shoot me an email or something like that, I'll be happy to take a look at it and get back to you.
Okay.
Thank you.
So when you talked about the retaining wall, you said Johnson or to put some sort of barrier to prevent the moisture drive. Some days we looked at that, we were going to put tampers on the back side of